Okay, we will see the best case now. We will go to see the best case. Again, a small problem, guys. I wrote an algorithm. I missed here. Something I missed here. So rest. Okay, everything is okay. Copying everything. For last element, I'm missing here. Last element, what we are doing, whatever the things rest is there, I will go to copy here. Copy the remaining element to array B. Okay, that's it. Array like this. Okay, that's it. This is an algorithm, merge algorithm. Okay. Now see here, for best case, I'm telling you about for the best case, I will going to show you here. Let's take something like this. So this is an array. Nobody will explain this much part. Eight. Okay. Okay. So here I will going to take the indices 1, 2, 3, 4, 5, 6, 7, 8. These are the indexes. Now I will going to take the value. See, the values matters here. Okay, 40. Again, take 50. Again, 60. Again, you take 70. Okay, 80. Again, 90. Okay. Again, 10, 20. Take one more, no problem. 30. Okay, this is the 9th index. You take it. Okay, now please observe the case is in this case, everybody please observe here. Suppose it is divided like this. In this way. Mid is here. Okay, mid is here. Mid is here. Okay. Here you can able to see how many elements are there. Totally 6 elements are there. Okay. Here totally how many elements are there? 3 elements are there. Let's call this one as M as well as N here. No problem. Okay, these two. Now when you see this one, what it indicates very clearly, when I do the comparison, that's what I told you, from year to year. Okay, which one is suitable, which one is lesser, it will go to that particular place. I will show you directly to that also. That one also I will show you, no problem. It takes very less time. Okay, now see here, compare this one. What is that? 40 and 10. Okay, 40 and 10, which is least? That is 10. Okay, fine. Again, compare this one. 10 is over actually. Again, 40 with 20. 40 with 20. What is that value? 20. Okay. Again, here you will going to get the what is the values? That is 10. You will going to get it. 20. You will going to get it. Again, compare. What is that value? 40. Again, 30. Like that, you will going to keep on continuing that one. Okay. Here you will going to get 30. Place it 30. No problem. Over. Nothing but completely with one comparison. With this one comparison. Okay. See. Comparison is how much? 1, 2, 3. With 3 comparisons, what I'm doing, I'm able to complete this particular indexes. Nothing but right array is completed completely. Now, what is the tension now? No need to worry about this one. Yes or not? Again, it's very easy. Yes or not? Again, it's very easy. If you are able to find the minimum, okay, this is completely minimum sorted array. This is also minimum sorted array. So it is start from 40, 50, 60, 70, 80, 90 up to here. Again, it will going to start from 10, 20, 30 like this here. Once you understood this array is completed, nothing but this is exactly, we know that it is already sorted. What we have to do now, just I have to move the elements to this particular array or not. Okay, so let's consider this one as A. Again, let's consider this one as B. Okay, It's very simple actually. When you know this one, these are all already we moved to this particular array means what is there in that. This is also sorted, nothing but just what we have to do. Just in it's in a logic understanding that I have to move all these elements to this particular index. Yes or not? This particular indexes we have to move. That is what exactly. Next, what it will going to move? 40, again 50, again 60, again 70, again 80, again 90. Over. That's it. It is the best case or not? So when you go back here, when you go back here, when you go back here, how many comparisons and how many complexities are arising here? So many comparisons are required here. How many comparisons here doing? Very just 3 comparisons. But if you go that particular problem, you will going to do 7 comparisons. Yes or not? 7 comparisons you are doing. But here only 3 comparisons. This is the best case or not? So this is the best case actually. That is what I wanted to show you people, nothing else. Okay, there is a best case, there is a worst case, depend upon your inputs. Okay, depend upon your sorted 2 arrays. Okay, 2 arrays you will going to get, that is sorted one, depends upon that. Again, whatever the inputs which are available, based on that it will going to be decided. That is what you have to understand. That's why I showed you very important one. Okay, this is very important one. That's why I showed this. Okay, now finally what you will get? 10, 20, 30, 40, 50, 60, 70, 80. So here you can able to see now comparisons here. How many comparisons? How many comparisons here? Very simple. How many totally? How many elements are there? 9 elements are there. Okay, 6 one side, left side, 3 elements another side. Again, how many comparisons? 3 comparisons. Okay, nothing but this is here. I will say that what is that? M comma n. You can see that one n. You can say like this: n by 2 into n by 2. So that is equal to what you will want to get it, n by 2. Okay, here one more important, m into n. Okay, it is into, not plus here, not plus here, it is into. Okay, so totally minimum we will going to get it, minimum we will going to get it m and n. That's it. Okay, so comparisons, how many comparisons you will going to have? Only minimum of m and n. Okay, minimum of m and n. Again, moves, go to the moves now. Go to the moves now. Okay, so how many elements are there right now? 6 plus 3, 6 plus 3, how many? That is 9. Okay, again here you can able to see n by 2 plus n by 2. That is equal to, you will going to get the value n. Here it says that very clearly, 6 is nothing but what exactly? That is m. Again 3 is nothing but what exactly? That is n. So m plus n. Okay, so this is what exactly. Here also same thing, time complexity is nothing but here also moves. Okay, for worst case also you will going to get m plus n. Again for best case also you will going to get m plus n. Okay, here also you can see, what is that? Here also you can see you will going to get the m plus 1. Again for best case also you will going to get the m plus 1. This one you have to be careful guys. Okay, you have to be very careful. So time complexity is equal to, okay, so that is equal to big O of m plus n. That's it, over. Okay, so this is a comparisons, just a small example I given you. Okay, again small note I will going to write here. Again now I will going to finish with the algorithm. Note, you take it. Small note. What is this note? Is nothing but merge two sorted, merge two sorted of each size m and n will take theta of m plus n for every case, because of moves, because of what? Moves, because of moves. So m and n is nothing but where it exactly, this is for outplace, this is for outplace. Okay, again this one, whatever the things we have discussed, okay, it will going to take the space n space extra. There is a one more reason I will going to tell you. See here, for comparison also it is taking, suppose you can able to say this is n, space is n. Again here also it is taking n space, one more array, this is also one more array, this is also one more array. If algorithm is taking, please understand, if algorithm, merge algorithm here, merge algorithm, I'm talking merge algorithm, taking more than n space extra. Okay, if it is taking n space extra, nothing but that is the worst algorithm. Okay, it should not, any algorithm should not take the space more than log n, more than log n. Okay, it should not take more than log n. Please understand, more than log n. Any algorithm should not cross this. If it is crossing this one, means definitely it is a worst case. Okay, worst time complexity, space complexity, sorry, not time complex, space, worst space. That algorithm is not suitable, waste algorithm. Okay, that is really waste algorithm. More than, okay, log n not allowed. So that is the reason why it is called it as out space also, out space. That's why it is taking, here also I am using the space, here also I am using the space, nothing but n into n square it will become, yes or not, 2n it will become. Okay, so that is the reason why what happens here basically. So we will not going to support this kind of algorithms. That's the reason why outspace, this is totally outspace algorithm. Okay, be careful. For that one I will going to show you this one also. Please observe here. See, what about this space is nothing but exactly, suppose think like that, a value is equal to 10, b value is equal to 20. Okay, if you want to swap, what you will going to do, you will going to use the one variable, that is temporary variable. I will going to assign the a value to t, nothing but a value is 10, t will going to get the value 10. Again what I will going to do, so a value already given to t, nothing but, so b value I will going to give it to a. Again finally what I will going to do, t value we having 10, so the t value I will going to give it to b. Okay, in terms of space point, okay, here in terms of space point, this is the worst one. Okay, in terms of space, this is the worst one, because too many, say, see here also one variable, again here also one variable, here also three variables I'm using. Okay, so how to make it best? Very simple, I can write this one also very easily. Suppose there is a plus b, what it will become, it will become 30, correct? A value is 30 right now. Again b is equal to a minus b, nothing but 30 minus b. 30 minus b, what you will going to get, b value you will going to get something like 20. Yes or not? Okay, so 30 minus b, okay, 30 minus b 20, you will going to get the b value 10. Here b you will going to get the b value 10. Again what I will going to do, a is equal to, okay, a minus b value is 10 actually. Okay, so like that you can able to interchange the values. Now you can able to see, sir, you said this one having a worse time complexity, what about this? See here I am using only two variables, a and b. That is the reason why when you are writing a program, or when you go to the interview and all, you have to take care about space also. Okay, you should take care about space also. If you are writing a program like this, they will understand you don't know how to maintain the memory. Okay, they will understand like that. Okay, be careful while writing like this. Okay, so always try to write like this, that is better. Okay, and one more thing, another one important thing I will going to tell you here, time. Okay, in terms of time, for execution it will take a lot of time. That is the reason why here this is also not, means this is okay for, in terms of time this is okay, it will going to execute faster. But here when it comes to time, really bad, really bad, because the reason is a will going to update so many times, b will going to update so many times. So that is a problem here. So in terms of time bad, in terms of time it's good. Okay, that is the reason why when it comes to time complexity, what we have to write, like this you have to write. When it comes to time, like this we have to write. So that's why knowing both, it's a good idea. And writing program, basically it's your technique, how you want it, you can able to write it. It is up to programmers. Okay, I can't say that you have to write like this, write like this. In interviews they will want to ask both the things, that's why you have to be very careful about this. Okay, that's why a small example I given for time and space. Okay, that is what I told you. Okay, so very simple one actually. let's it's take n square. When it comes to time and the space, dear, I mean merge sort, it will going to take, in terms of space, it will going to take n square. Okay, so that's why it's very hard for the programmer to maintain the memory. Okay, so let's take the algorithm. This here, let's take the algorithm. That's why I showed you the swap also. We can go to that one again. That's what I told you in merge algorithm. What happens here basically? So finally, you will go to elements have like this. You will going to have a constant element. You wanted to swap means you can use the technique, whatever the technique you wanted, you can able to use it. So why I'm discussing about this one? The reason is here there is a problem here. Okay, consider the elements like this, something like 50, 60, 70, 80. Okay, and here 10. Okay, 20. Get this. It's playing with me. Okay, so here see everyone, 50, 60, 70, 80. Okay, here 10, 20, 30, 40. Okay, now so what I will do, it's a divided. Okay, now if I want to swap this one, okay, I wanted to swap all these numbers. I want whatever the element, this is the first element. Okay, it is the lowest one. What I will do, I will go to bring this one 10 over here. Everybody observe here, please. I will go to bring the 10 over here. I will go to shift this 52 over here. Okay, after that, what happens here? Exactly, you observe here. Okay, again for 60, again 50. Again I have to bring the 50 here, again I have to shift the 60 here, like that. So many things it will going to happen. So then what happens exactly? Every time one comparison, every time you have to compare, every time you have to compare, every time you have to swap it. Nothing but it will going to take n number of times. Yes or not? N number of times. What happens? Totally n square it will become. Okay. So here you wanted to make it very easy. Okay, comparisons and all. So that time what it will going to give you exactly means in place values. In place values nothing but make it so easy so that you can able to compare each other, and you can able to make the space less, and you can able to execute faster. So that value you will going to get the n square here. Okay, so this is in place values you will going to get it, but don't worry about all those things. It is totally highly what we can highly complex one. No need to understand, for you people not required, but it's okay. Just have an idea. But we'll go to write algorithm now. Okay, so let's write an algorithm for merge sort over. That's it. Merge sort. Okay, na? So until we have discussed everything about the merge sort, inside that there is a function that is called as merge algorithm. Now completely we are discussing about the merge sort algorithm. I am writing now merge sort algo. Okay, I'm writing merge sort algorithm. Everybody ready? Okay, let's see. So first what we're going to do, we're going to take an array as a so merge. Okay, let's take an array that is called it as a. Again initial index is I, again final one is j. Okay na, this one everyone okay? Fine, I think everybody okay. Again this function I will going to call this one as tn. Fine, that is also over. If okay, I value equal to j value, what we will going to do basically? So we will going to suppose nothing but what exactly I'm telling here. If it is a this condition is called it as termination condition. That's what I told you. If you are doing a merge sort, if there is a only one element that is called it as 10 with index is I, j also over here, I plus j, what you will going to get it? One only. So then what is the element you will going to sort? That is 10 only. That is the reason why I'm writing I value is also 1 year, again j value is equal to 1 year. So what it will going to return? It will going to return, see here, it will going to return, what is that? Array. What array? Yeah, that's it. Okay, I think everybody clear. I'm writing algorithm, not the program. Please understand, this is not the program. If you want it, you can remove these things, not at all required. Okay, else if you have array is bigger one, this is a smaller one, if it is a bigger one, what do you have to do? So for that we have to first, what we have to do, we have to create a mid. Yes or not? We have to do the mid. So that's why mid is equal to very simple. Actually, algorithm is very simple. I plus j. That is what we have. I showed you here. I here j. Okay. Take like this one more if you want it. J. Okay. I plus j divide by 2. I am taking floor value here. Yes or not? So this how many, what is the time it will going to take? It will take the time constant big O of 4. Okay, big O of 1. Again here also you can able to see. Okay, what is the time it will going to take? This is also constant actually. This is also constant. Okay, fine. Again now after doing this one, what we will going to do, we will going to use the recursion or not. So just I will going to put the recursion so that I wanted to sort, and again I have to divide. See what I will going to divide this one until where I have to divide, until I get the single element. Yes or not? So that's why I will going to apply the recursion for this particular array. I will going to apply for recursion for this particular array. So that's why what I will going to do, I will going to create a recursion merge sort. So if you want it, you can able to write here merge sort like this. Okay, same name. This is also same name. This is also same. Now what I will want to do, from where to where? So here started from j to mid. Yes or not? That's the reason why array a, again starting from I, again up to where? Mid. That's it. Okay, it will go back here. Again it will going to check one or not. Again it will going to divide that array. That is what exactly it will do. What is the time complexity here? T by 2. Yes or not? We divided, so that's why. Okay, so t of n by 2, sorry, n by 2. Correct, huh? Again one more, this array is over, left side is over. What about right side? You have to say or not. That's why merge sort array. Okay, where it is starting from? J is nothing but what? Mid plus 1, mid plus 1, mid plus 1, comma, up to where? Up to j. Okay, that's it. Okay, fine. So this is also, it takes t of n by 2. Right? Now again over these things, everything is dividing is over. Suppose these are 1 2 3 4. Okay, what I will going to do, first we will going to divide into two parts like this. Again we have divided into two parts. First is like this. Okay, again I will going to apply the regression. Finally we will going to get the single element or not, like this, single element or not. Now what we have to do, we have to merge it or not, we have to apply the merge algorithm. That's why here I'm going to write in red color. So merge function. That is the reason why I explained all these things. Okay, nobody will do this. Okay, fine. Mid, yes or not? Array starting index up to mid plus 1 also. Okay, up to where? J ending index. Yes or not? This is, we know that this is outplace because takes lot of space. That's why outspace. Okay, again execution time n. Okay, again finally what it will going to return what it will going to return? A, nothing but array. Okay, complete this algorithm. That's it, over. Else part is over. Again complete this. Oh, that's it, very simple. Okay, so finally what is the time complexity for this one? N by 2 plus n by 2, you will going to get the value n, nothing but totally big O of n. So this is the time complexity for this. Okay, again one more last thing I will going to tell you, one more last thing, how to find a recurrence relation. So that's what, for recurrence relations here, everybody, for recurrence relation here I'm writing a recurrence relation. Everybody observe here, t of n here, everybody, t of n that is equal to time complexity. Okay, here for how many elements? For n elements. For n elements, here now t of n that is equal to big O of 1. Why? Because if n value is equal to 1, nothing but one element. Already I told you. Now you people got it, everything. Again C, nothing but constant. Again, so there n by 2, what you will going to do? 2 t of n by 2. Yes or not? plus function, merge function n, if n value is greater than 1. Yes or not? If more than one element means definitely we will going to do the else part. So else part is nothing but we will going to get the recursive relation. So now, okay, this is all about first level. Whatever the things I discussed right now up to here, this is a first level. This is the first level. So recursion, we got it. Okay, so here what are the things are there? Divide time as well as combine time. So here combine time as well as divide time, you people are getting. Okay, constant is nothing but divide time. Again this one, combine time. So that is the reason why I wrote these things. This is the first level. Now I will going to find the recurrence relation for this. Now everybody observe here. T of n, that is equal to, write it as it is. Okay, 2t n by 2 plus n. Now in place of n, everybody in place of n, substitute n by 2. So what is the value? We're going to get it 2 into, okay, 2t, okay, n by, it will become 2 square or not? 2 square, okay, plus n by 2, again n, plus n over. Now finally what you will going to get it? So 2 square multiply 2 square t n by 2 square, yes or not, plus n plus n. Yes or not? 2 2 cancels. Okay. Finally, one more level. Write one more time. 2 power 3. Same thing. T n by 2 cube. Correct? N by 2 cube plus n plus n plus n. So this is the final one. You will want to get it. Okay. Now apply for log n times. Log n times you apply this one. So what is the value you will going to get it? Let me write here. Otherwise, I will going to write here. No problem. Now 2, it's there, right? 2 power log n base 2 t n by 2 2 power log n base 2, it will become 1. I will show you that one, don't worry, plus n log n. Okay, na? Now finally n into, yes or not? So this will become 1, yes or not? This will become 1, it will become n totally, n log n. So it will go here again n. Okay, that's the reason why n here. Again t of 1 here, yes or not? T of 1 plus n log n. If you have any doubts here, it's nothing, it will become 1. Okay, that is what exactly. So that is the reason why 1 here, again log n. Fine. After that, what you will going to get it here, n is there, so that's why n plus n log n. Okay, n plus n log n. Now take this as per the recurrence relations. What you will going to do? Theta of n log. So this is the time complexity for, what is that? Merge sort. Merge sort. Not merge algorithm. Hello, not merge algorithm. This is the time complexity for merge sort. That's it. Okay. Again, if you want it, space complexity. So space complexity, big O of n. That's it. Okay. It will take n. Because same array it will going to return, right? That is the reason why n. And when it comes to total space, okay, so final space, it is n, okay, but it will going to occupy less than n. That is the reason why I will going to say log n here. Actually not completely n, it's, I would say big O of log n. It takes less than n. Okay, not n. That's what I told you. I have to justify. That is the reason why I told you it should not take n space. It should take less than n space. Okay. So this is all about your space complexity. This is all about your time complexity. So finally, once again, I will going to write here, time complexity is equal to theta of n log n. That's it. This is your final one. Okay. So this is all about your merge sort. Detailed explanation about merge sort. Okay. Find anywhere, you're not going to get it here. Fine. Anybody have problem? I think nobody have problem. Still, if you have any confusion, you can ask me. Okay. So this ends your merge sort.